used on a lesson, go back and watch the instruction, okay? Let me go get you some more markers. So, Mr. H is not talking, but he is writing. So, you should be writing too. Okay, if you're not writing, go ahead and do that. So right now it says, Unit 5, Multiplication and Division, Day 3, Rational Numbers. When we talk about numbers, we've got a list there. Set of rational numbers, natural, which are our counting numbers. 1, 2, 3, 4, 5, 6, what you learned in preschool. No?
I'm just really disappointed. I was going to see how long they went. I was going to start talking.
Oh, okay. I'll ignore you then.
No, keep on going. Now you're there. Now you're thigh deep. No, I want you to, Miss Armstrong.
I don't want to.
Miss Armstrong, do you feel better?
A little bit.
What do you need? Do you need a hug? Jackson, give her a hug.
No, I don't want to spread my germs to Jackson.
You wanted to earlier. You wanted to pass up the germs. We have two sets of numbers. We have real numbers. We have imaginary numbers. You will not be dealing with imaginary numbers until you get to trig. So you won't see those for a while. Actually, it's going to be algebra 2. We're going to talk about I, which is the square root of -1, but you can't really have a square root of -1 because it's impossible, hence why it's an imaginary number. But we're not there yet. So we stay in the real number plane. Natural numbers are what every kid starts off learning. When I teach Cole to count, I don't say, okay, Cole, how many ducks are there? And he looks around and he finds a duck and goes, duck! Well, yeah, but that's not starting at 0. So we don't start at 0 for natural numbers. We start off at 1, 2, 3, 4, because that's how we learn to count. Most parents don't say, okay, let's start to count. 0, 1, 2. I'm sure some parents do. Most don't. Whole numbers. The way that I like to think of a whole number is that 0 is a whole. The only difference between natural and whole numbers is that 0. With me still. Then we get to integers. And we've talked about these all before, and you've seen these all before. But, you know, I wanted to give you a list so you can see exactly which things are what. Integers go forever in two directions. -3, -2, -1, 0, 1, 2, 3. The way that we think of integers are they are our whole numbers and their opposites. So when we think of a whole number, is 100 a whole number? Is 100 a whole number? What's 100's opposite? Ella? What's the opposite of 100? Well, let's do it this way. So here's 2. What's the opposite of 2? Okay. Yeah, so the opposite of 100 would be -100. That's how you think of integers. It's the whole numbers and their opposites. And then we get to the one that we will be dealing with, which are rational numbers. Now notice, 1 is an integer. 1 is also a whole number. 1 is also a counting number, which is a natural number. So, with that being said, if I said, name what 1 is, you'd have to say it's a natural number, it's a whole number, it's an integer. I'm glad that we don't have to do that for our class, for our curriculum. Used to. Curriculum changed. But rational numbers are the same thing. It can be our integers. It can also be fractions, both positive and negative. It can be decimals that terminate. Terminate means end, unless it's the Terminator movies and then they go on forever, I feel like. Like there's 7,000 of them. None of you were alive when those came out. You're like, Arnold Schwarzenegger, that old guy? He was one of my idols. I would be back.
Arnold.
Then he became the governor of California.
I'd stop right there with the narration.
He's a big guy. He's a big guy. He's still a big guy. You can also have repeating decimals. Those are all rational numbers. So what is today's lesson? Well, we're still doing multiplication and division, but we're going to be dealing with rational numbers, which include positives and negatives. And I would love to say this lesson is hard. Truly and honestly, I could probably test you tomorrow. That's how easy this lesson is. Mrs. Armstrong and I have talked about this and we've tried to figure out how long do we think this is going to take. This is so unbelievably simple to teach that we feel like it should be simple to learn, but it's not always easy to learn. And that's understandable because you've never dealt with negatives before. It's a new concept. So, if at any point this is one of my weaknesses, it's one of my weaknesses, I think it's easy. Not you. I think it's easy. If I start going too fast and you're like, Mr. H, it's not easy, I'm having trouble, let me know. Because sometimes I'm like, yeah, we're doing great. I'm doing great. Here I go. And then all of a sudden you're like, no. Okay? One of the things that I do is I always reassess. After a class, I will almost 9 times out of 10 days, I'll usually go to Miss Armstrong and say, okay, how do you think that went? Some days she'll go, they did really well. Some days she'll go, wow, you should really not do that again. I mean, usually I change it for my 3rd hour and then I change it for my 6th hour. You guys just happen to be the guinea pigs. Okay? So, if I go too fast, you have to let me know. Everybody with me? Okay. We are only going to multiply 2 numbers. We are only going to divide 2 numbers at a time. So that's the first thing I want you to understand. No matter how many numbers are shown, we will only deal with 2 at a time. Okay? So just like in addition, sometimes there were 3 and 4 numbers that we were adding and subtracting, right? We didn't look at the whole problem and say, I'm going to try to add all 4 numbers at once. No. We dealt with 2 at a time. Same thing with multiplying and dividing. We're going to multiply with 2 at a time. We're going to divide 2 at a time. Simple enough? Okay. How do we know when the product, when I say product, what is a product?
When we,
Go ahead.
mathematically, what is a product when we talk about a product? What is the mathematical definition of a product? How do you get a product?
Renee? The answer of what? What kind of problem?
What operation? Yeah.
Yeah, this is the answer to a multiplication problem. So how do we know when the answer to the multiplication problem, product, and then I'm going to throw another word at you. This one's the tougher one. Quotient. What is the mathematical definition of quotient, Brooklyn? The answer to a division problem. So how do we know when the answer to a multiplication or division problem is negative? Okay, that's what we're trying to figure out today. You should not need to work out any of the math to be able to tell me that's going to be positive, that's going to be negative. Should not need to do the math to tell me whether it's going to be positive or negative. Everybody with me still? So, I'm going to come back over here. I'm going to erase our set of real numbers that I was doing so quietly. And then somebody decided too quiet. It's a little creepy when I'm quiet, isn't it? So it's a little creepy. I like your sweater, Anna. You're welcome. I do, I like that color. Okay, so how do we know when the product / quotient is negative? This is for both multiplication and division. So once again, listen. How many numbers are we dealing with at a time? 2. So, if I have 2 positive numbers, and I hope you know that long before Twitter, long before Instagram, this was the pound sign. This also stands for number. This does not say 2 positive hashtags. Okay? So this says 2 positive numbers. If we have 2 positive numbers, what's our answer going to be? Say it in. Positive. No matter what, if we have 2 positives when we multiply and divide, we will end up with a positive answer. So far, that's all you've ever done. 3 times 1, and you shout out 3, and I go, yay! Because it is 3. But you don't tell me it's positive or negative because we know it's positive. Well, there's only one other option. Well, actually, there's 2. 1 positive and 1 negative. The answer is Lauren?
Negative.
Lauren! I just said a lot of letters there, and I was trying to say Lauren, very excited. Try it again. 1 positive and 1 negative. The answer is?
Negative.
Lauren! Great job. It is negative. So if I say negative 3 times 1, you'd shout out. You're not shouting out anything. Wait. Okay, let's try again. I'm going to say negative 3 times 1. Then I'm going to go 5, 4, 3, 2, 1. And you're going to tell me an answer. Okay?
Everybody at the same
Everybody
time.
at the same time. But when I say shout, you're going to whisper it. Okay, here we go. Negative 3 times 1.
Negative 3.
Okay, let's try this. I'm going to get in front of the camera so the camera can see it this time. We're going to do this one more time. I'm going to say negative 3 times 1. Then I'm going to count 5, 4, 3, 2, 1. And then I'm going to point to you, and you're going to whisper the answer. You with me?
Yeah.
Okay.
So when Mr. H points, you talk.
Okay. Negative 3 times 1. Perfect. It is negative 3. How do I know it's negative 3? Well, the multiplication doesn't change. The only thing that changes is we had 1 positive times 1 negative. 2 negative. That's not, there we go. 2 negative numbers. The answer is, wait, I love this. Lauren!
Positive?
Yes! Lauren! I'm proud of you, honey. I think this is the most that you've talked in class ever, and you're doing great. Thank you. Come on, Jaden, step up. Lauren's crushing you right now. Lauren, that's great. Lauren said it was what?
Positive.
Very good, honey. It's positive. Okay. Same deal. We're going to count. Yeah? We're good? Okay. Negative 2 times negative 2. Okay, we're going to do that again because only like 3 people said the answer. So it's negative 2 times negative 2. So think about it. Negative times a negative. Okay, here we go. Negative 2 times negative 2. Okay. So I had a couple that were wrong, and that's what I wanted to hear. When it's a negative getting multiplied by a negative, 2 negatives, the answer is positive. Okay? So, I want to do it this way as well. This is great when we're dealing with 2 numbers at a time. This will be your main notes for the day. Okay? This will be your main notes for the day, but I'm going to add on because sometimes it might ask you a problem like this and tell me whether it's positive or negative. And without looking at it, or without trying to do each individual thing, you're going to need to be able to figure it out. So here's a way when it's not 2 numbers. The answer will always be positive when the number of negative signs are even. What do we mean by even? If there's 0 negative signs, the answer is positive. If there's 2 negative signs, the answer is positive. 2 negatives is a positive. If there's 4 negative signs, it's positive, and so on and so forth. So to figure out whether this problem is positive or negative, let's count. 1 negative, 2, 3, 4, 5, 6, 7, 8. Is this positive or negative if it has 8 negative signs? Raise your hands. Is it positive or negative if it has 8 negative signs? Jaden?
Positive.
Why? What is 8?
It's an even number.
It's an even number of negative signs. Okay? Well, So negative, the answer will be negative when the number of negative signs are odd. Well, what are our odd numbers? If there's one negative sign, it will be negative. 3, 5, 7, and so forth. Now remember, are we adding and subtracting right now? Are we adding and subtracting? No, these rules do not apply for adding and subtracting. These rules are only for multiplication and division. Both ways of seeing the rules. These are really the same thing. Because two positives are 0 negative signs. One negative is an odd number of negative signs. Two negatives is an even number of negative signs. So I've given you two ways to look at it. Whichever one suits you, use. Everybody with me there? Okay. Let's try a couple problems. Do we have this portion written down? Do we have especially this portion written down? Yes? Okay. So you just got back your quizzes on fractions, right? We know how to multiply and divide fractions, or we should. So I want to jump you into the deep end immediately. So here's our first problem. Try it on your own. When you have it, raise your hand. Negative 3/2 times 4 by 4/3. Actually, I don't like that. Don't do that one. Times 1/5. I like that one better. So negative 3/2 times 1/5. Show your work. Raise your hand once you have it. Show your work. Raise your hand once you have it. Good. Good. Now, look at your rules for positives and negatives. That's the whole key to this lesson. It's figuring out whether it's going to be positive or negative. Good. 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 You have the same exact. Oh, okay. Good. Good. You just had your hand up. Yes, you're finding the answer. Correct.
Yeah.
Good. Good, Jackson. Good. Good place. Okay, so let's just start with this. Is it positive and negative? Let me just get it. Is it positive or negative, and why? Positive or negative, and why? Trinity. There are 1 negative signs. That makes them odd. So the answer is negative. Before anything else, I want to know, is my answer positive or negative? And then I'm going to put the sign. Everybody with me there? It's a fraction, so I'm going to keep my fraction bar. We multiply across. 3 times 1 is 3. 2 times 5 is 10. Can I simplify? Because you would still have to simplify if needed. We're there. Questions on that one? Okay, making it a little bit trickier. Negative 2/5 divided by negative 3/2. -2/5 divided by -3/2.
When you have an answer,
Raise your hand. Can't wait. Perfect. Perfect. Good job, Jade. Great job, Jade. Good job, Legs. Good. Good.
Nice job.
Rock star.
Yes, ma'am. Nicely done. Do that.
Okay, here we go. This Jackson. How many negative signs do I have in this division problem?
2.
2. So does that mean my answer will be positive or negative?
Positive.
Positive. Even number 2 will be positive. So, can I just start? What do I need to do when it's a division problem? When we have a fraction divided by a fraction, what do we have to do? Come on, I need some new hands. We got these same two. Ms. Adams.
Find your reciprocal. Or like,
Talk me through the whole process like you're rally coaching me. So tell me what I need to do first. Do we have to rewrite first?
Yes.
Okay, what am I going to rewrite?
-2/5 times negative,
Can we use a better word than times?
multiplied
Okay, multiplied.
by -2/3.
Good. And -2/3 is my what?
Reciprocal.
Okay, so we're only using the reciprocal of that second number. Mr. Vescovi already told me a negative times a negative was?
A positive.
Positive. So I just put my fraction bar. Notice when I'm multiplying, because I already know it's positive, do I even worry about the negatives anymore? Nope. So I do my numerators. 2 times 2 is 4. Denominator times denominator. 5 times 3 is 15. And I said 5 times 3. I screwed up. 5 multiplied by 3 is 15. Gives me 4/15. Hard? -2 1/4 times 2/3. -2 1/4 times 2/3. Try it again. -2 1/4 multiplied by 2/3.
When you're finished, look new. Make sure you're simplifying. Yes. Simplify that. What is the, you can simplify that.
Somehow you flipped this. I'm not sure what happened. Yeah, I think you got them mixed up. You're good, Aiden. You're good too.
I'm not seeing as many good answers. We're forgetting to simplify.
Hey, I have it right. I do.
Oh, wait, yeah.
I'm seeing a lot of people forgetting to simplify. I'm seeing some people multiply by the reciprocal, and I'm seeing some people not use their negative signs. Okay, well, I've got to be able to see the negative sign, okay, so that is correct.
Not so hot on this one.
Not so
Doesn't
hot on
seem.
this one.
Because I even-
It's so hot on this one.
Some people did. I'd say 50-50, Mr. H, but a lot of us forgot to simplify that very end, and some of us forgot what to do with the negative sign.
Okay, so let's just walk through the process. Here's what I like to do first. Let's pretend that there's not a negative here. Because we know how to do this problem without a negative. We cannot have a mixed number. We want an improper fraction. I multiply my denominator by the whole portion. I get a product of 8. Then I add my product to my numerator, and I get 9 divided by 4. But this mixed number was negative, therefore this improper fraction has to stay negative. Everybody with me there? Now we're multiplying by 2/3. Immediately, how many negative signs do I have, Mr. Ewing? 1. So is my answer positive or negative? Negative. So I'm going to immediately put my fraction bar, and I'm going to make a big solid negative sign so that there's no doubt that your teacher can see that it's a negative. Then we multiply numerator times numerator. Numerator multiplied by numerator. Denominator multiplied by denominator. And we're not done. They're even. T, what do? So this fraction can say they are what by 2? Divisible. Now here's my question. Is my new fraction positive or negative? We don't lose that negative sign. 18 divided by 2 is 9. 12 divided by 2 is 6. So now I have negative 9/6.
And so, Mr. H, if I were going to say what my favorite mistake was today, lots of us stop right here. Okay, many of us stop at negative 9/6.
Lauren, you're saying no. Why not? What do we have to do still?
It's divisible by 3.
Great mathematical terminology. It is divisible by 3. Brooklyn, what type of fraction am I going to have? Positive or negative? Stays negative. 9 divided by 3 is 3. 6 divided by 3 is 2. I'm left over with negative 3/2. Tomorrow, you will see multiplying and dividing fractions with positives and negatives. We will eventually get to simpler problems like -7 times -8. And I say simpler because you know how to multiply 7 times 8. It's just the negative. But let's stick with what we've just been doing, which is the fractions. You do not have homework tonight. You will tomorrow. Letting you know that. So make sure that you have good notes copied down.